And welcome to this video, which we're going to be talking about properties of special quadrilaterals. And specifically, to kind of go a little bit more detail about that, we're going to be talking about properties of rectangles, rhombuses, and squares. So you might know a lot about these shapes already coming into this lesson. And what we're going to do in this video is we're going to talk about how to connect them together and show you what the relationships they have with each other. This Venn diagram down below here actually should hopefully give you some sort of indication of what their relationship is. But let's go ahead and let's dive into that. Before we do that, though, we're going to talk about what you learned in the last lesson, and that was about what properties or features a parallelogram must have. And so these were the 5 properties that we discussed in that lesson, that they have to have 2 pairs of parallel sides, congruent opposite sides, congruent opposite angles. The diagonals are going to cut each other into 2 equal parts. And lastly, you might not recognize this word, consecutive angles. That's the same thing as me saying same side interior angles. So let me write that down. Same side interior angles are supplementary. Now you're probably wondering, there's no notes to take just yet. I will get to that in just a moment when we get to the flow chart. So what we need to discuss here is just an idea of what it means for something, for a shape to be another shape, but not possess the same qualities in reverse. So what do I mean by that? Well, for example, a rectangle is going to have all of these properties. So technically a rectangle is considered a parallelogram. However, all parallelograms aren't necessarily rectangles. So that statement seems confusing when you hear it out loud. But let me give you a more concrete example to start that. All right. Let's think about math class. All right. You are currently in a math class. If you're watching this video and you're in my geometry class, you are in a math class. However, we don't necessarily call it math class. We call it geometry because it's a specific type of math class. So it is absolutely true that you could walk into my class and say, I am in a math class. That would not be an incorrect statement. Just like you are technically allowed to look at a rectangle. Oops, let me get back to that. Sorry. You can look at a rectangle and say, well, that is a parallelogram. So, and you wouldn't be wrong. You absolutely wouldn't be wrong by calling that a parallelogram. However, just like we can call my class a math class, most of the time we call it a geometry class because that is a more specific name of the specific math that we are actually doing. So because of that, we probably wouldn't want to call this a parallelogram because that's not specific enough. All right. We want to give shapes the most specific name that they can. And so while that shape is a parallelogram, what we're going to more or less call it is a rectangle. So that's the relationship in terms of these different shapes we're going to look at. And on the first page of your packet, you will see this large flow chart. And basically over the course of the next couple days, we are going to go through this flow chart and fill out all of the properties. We're going to fill out a little more than half of it right now in this video. And you're going to have a chance to pause the video to write down these properties. We have our overarching quadrilaterals. That's everything we're studying in this unit, 4-sided shapes. And then they're going to split off into 3 specific types. Parallelograms, which we learned about in the last lesson, kites, which we'll learn about later, that's not today, or trapezoids, which is also a separate lesson. So we're going to move down and look at parallelograms. And inside of the parallelogram world, there are 2 specific types of parallelograms. They have the rectangles and you have the rhombuses. And we're going to learn about those properties in just a few seconds. And lastly, once you learn what a rectangle and a rhombus is, we can actually take those properties, combine them together, and what we create is a square. So the majority of this video is going to focus on these properties down here that you see currently on the screen. So let's go through for the next couple minutes and have you write down some of these properties of some important characteristics, and then we'll get into some specific examples. So let's start with quadrilateral. So at the very top here, you want to write down, these are the 2 main properties of a quadrilateral. All that has to possess is to be 4-sided, and the sum of the interior angles is 360 degrees. That's it. That's all you have to know about quadrilaterals. Keep in mind that you can pause this at any point so that you can write these down yourself. Next, we have parallelograms, which again are the exact same things I showed on the previous slide in the video. Both pairs of opposite sides are congruent and parallel. Both pairs of opposite angles are congruent. And lastly, diagonals bisect each other. A reminder that's really important to note here is I didn't write down that it's 4 sides because by being a specific type of quadrilateral, we are assuming that these two properties are automatically going to be true for parallelograms. Automatically going to be true. So that is exactly why I didn't write them down. These three things are specific things to parallelograms. Okay? Just like in geometry class, I don't write on the syllabus that we do addition, subtraction, multiplication, and division. Why? Because that's assumed that you do that in all math classes. So going into geometry, since you know it's a specific type of math class, you are assumed to do those basic operations in any math class. But in geometry, I talk about additional things or special things that we do that are only done in geometry class. So giving you that example, that parallel back to what we talked about earlier. So let's talk about some of the new shapes we're going to learn today. And the first one is going to be rhombus. All right. So the first thing to note here is it has 4 congruent sides, 4 equal sides. So notice that I have marked over here on the drawing these red dashes that represent all the lengths are equal. Okay. The diagonals bisect the angles of the rhombus. Okay, so what that means is that this is a diagonal right here that I'm drawing in purple. Okay, so I'm going to draw this diagonal in purple. Oh, actually, there's 2 diagonals, but I'm going to focus specifically on the longer one just for the illustration purposes. What it's saying is that this angle and this angle right here are the same. They bisect, which means they cut each other in half. And the last thing is that diagonals are going to be perpendicular to each other. And so you'll see that indicated here by the right angle. So it actually creates a right triangle. This triangle right here that I'm going to highlight in green is technically a right triangle. So a rhombus is actually made up of 4 right triangles that are merged together. And so those are the main properties that we have for rhombus. So let's look at an example of how we can apply these properties into a problem. So here's a drawing. You will find this on page 3 of your packet. You will find this problem. So the diagonals of a rhombus intersect at T. Given that RPS is 30 degrees, and you can see that that's indicated here in the drawing, and RT is 6. So the entire length, so I'm actually going to do this in red just to help you see this. RT is red. Draw a long line there. That red line is 6. We went on to find the oh, actually, it's not the whole thing. I apologize. It's only to the middle. So let me erase this portion. I misread the question. So the 6 only goes to right here to the center. Okay, so that part that's in red. All right. Now we need to find the indicated measures. So we're going to begin with finding QPR. So QPR is going to be this angle right here in purple. So based on the fact from the last slide that I just mentioned that diagonals bisect the angles, because of that, we can look over here and see that because the green angle down here at the bottom is 30, that this angle up here must also be 30. And so the answer to this first question is 30 degrees. Next, we're going to talk about QTP, which I'm going to do in blue. So that's going to be this angle right here. And what we know about this is going back to our properties, is that diagonals are perpendicular to each other. And so all 4 of these angles right here, all 4 of these angles are all going to be 90 degrees. And so because of that, we can immediately say that QTP has to be a 90-degree angle. Moving next, we're going to talk about RP. RP, as I almost incorrectly stated a minute ago, is the entire length of this diagonal, the entire length. Now, here's the tricky part. There's not a property that talks about the lengths of these diagonals. So we're kind of stuck here until we recognize that a rhombus is a specific parallelogram, which means all of the properties of parallelograms are also going to be true. And we know about parallelograms that diagonals are going to bisect each other. So if the diagonals bisect each other, this will also be true for a rhombus. Therefore, that 6 represents half of the diagonal. The other half must also be 6. That's why we're going to be able to say RP is 6. And that brings us to the 4th question, which is probably the hardest one. QT. How do I figure out the measure for QT? So the challenge here with this is that we don't know anything about this diagonal here. But there's one important thing, and I'm going to erase all of the scratch work that I've done on this drawing here to show you this. All right. QT, we know that QTP, is a right angle. If I know this is a right angle, and I know this triangle that I'm drawing for you in blue is a right triangle, we can utilize all of, and I'm going to trace it out down here in the bottom, we can use all of the knowledge that we know about right triangles, which we know a lot about, to help us figure this out. I know this angle is 30. We mentioned that earlier on in the video. We also know that this length right here is 6. And what I'm trying to figure out is what this measurement is right here. And so what I can do is I can solve this triangle either by recognizing that this blue triangle is actually a 30, 60, 90 triangle, or I could, and this is what I prefer you to do, is that we can just use sine, cosine, and tangent to help us solve this, keeping in mind that this is the opposite of my 30, and this is the adjacent of my 30. Therefore, in order to find QT, what we're going to do is we're going to find the tangent of 30 degrees, and we know that that is equal to x over 6. I'm going to put the tangent of 30 in my calculator, and we're going to get 0.577 equals x over 6. And then the last step I need to do is I need to get x by itself. So we're going to multiply both sides by that denominator. And when I do that, we're going to get a value of, and I'm a little bit out of space here, but x equals 3.5. And that's going to be the measurement for QT here is 3.5, and we're finished. So that's our first of our big properties. And the next one we're going to look at is rectangle, okay? And so there are only two major properties we need to look at for rectangle, and that is there are 4 congruent angles, which means all the angles are 90 degrees. So I'm going to write those down in green, okay? All of the angles are 90 degrees. And the second part is that the diagonal lengths are equal to each other. So what that means is when I draw from corner to corner, that these diagonals are going to be exactly the same. Now, a quick side note about this is you may notice when you go out to a store that you see television sets that are measured in inches. You can see if you want to get a 36-inch TV or a 40-inch TV or a 50-inch TV, 60-inch, and so on. What do those numbers actually represent? So when you buy a television, it is actually telling you the diagonal measurement of that television. And the question always remains, well, then, which way do you measure it? And the answer is it doesn't matter. When you look at a television set and you want to decide how big of a TV you can get, you actually need to look at the diagonal measurement because those measurements are going to be the same no matter which way you measure it. So a 60-inch TV is telling you that the diagonal of that rectangular television is 60 inches regardless. So that's one way that we can kind of remember that diagonal lengths are always going to be equal in a rectangle. So keeping that in mind, I also want you to keep in mind that a rectangle has no properties of a rhombus. So notice that rectangles does not have 4 equal sides or that the diagonals are perpendicular. That is just simply not true. So we need to keep that in mind as we move on to this next question. So this is, again, back on page 3. The diagonals of a rectangle intersect at P. We know that YXZ is 50. So YXZ is 50. YX, yeah, that's already labeled for us. I'm sorry. So that the 50's already been labeled for us. We also know that XZ, so I'm going to do that in green. XZ is going to be 12, and that's this entire length right here. That entire length that's in green. So we now want to find the different measures. And so we're going to begin with, and I'm going to keep trying to color code this. So purple, WXZ, that's this angle right here. Well, you might notice that we've already indicated that 50 was the angle here. This angle will not be 50 because, again, it's not a rhombus. What we actually have to identify is that this entire angle is 90 degrees. And since that entire angle is 90 degrees, if the bottom angle is 50, the top angle must be 40. So there's our first angle. Next, we need to look at WPX, okay? WPX, which I'm going to do in blue, okay, is this angle right here. Again, this can be a little tricky, and this is probably the hardest part of this problem in the sense of we don't necessarily know that angle because it's not 90 degrees. What we have to identify is we want to remember that the diagonals are equal to each other. Also, because, so those two green lines are equal. In addition, and I'm going to do this in kind of a pink color, we also know that diagonals bisect each other. And so these two, okay, are equal to each other. But that also means that because those green lines are equal, that these two sides are also going to be the same, okay? And because of that, what we create here is an isosceles triangle up top here. So the triangle that's up top here that I've drawn is isosceles, which means that this angle that's I already identified as 40, and this angle will automatically also be 40 degrees. Well, utilizing the idea of a triangle, and I'm just going to take this top triangle and I'm going to trace it over here for you to help you see it because there's a lot of stuff going on over there. If those two angles are 40, this angle right here must be 100, which gives this to be 100 degrees. Again, if you want to know why, the reason why it needs to be 100 is because the three angles of a triangle must add up to 180 degrees. Now, that kind of answered our next question already, because PY is actually asking us for half of the diagonal. And so we know it's half because, again, a rectangle is a specific type of parallelogram. So therefore, the diagonals are going to cut each other in half. So half of 12 means that PY is going to be 6. Final question for rectangle here. We're going to take a look at finding WX. So I'm once again going to erase everything just to kind of clean up the drawing. And in order to do this, I'm going to switch to green and we're going to look at WX, which is the length across the top here. Okay. We don't know what that length is. And in order to do this problem, what we run into an issue with is we have to look at making this a right triangle again. Unlike the last question, however, the right triangle is not going to go through the center because that's not where the 90 degrees is located. So this green triangle that I've drawn has a 90-degree angle here. And here's some other things that we know. We know that this entire diagonal right here is 12. We also know that this angle is 40. And so what we've created is another right triangle that we can use trigonometry to help me solve this. So 40, 12, 90, and then this top side is going to be x. And so my setup for this one is I have x, which is considered my adjacent side, 12, which is considered my hypotenuse side. And so we're going to say the cosine of 40 degrees is equal to x over 12. And that's what I'm going to do to solve this final question. So cosine of 40 is 0.766. And then we're going to multiply both sides by 12. So we're going to go ahead and do that. And so my x here is going to be equal to 9.2. So my length for WX is going to be 9.2 for the rectangle. Okay. And that's going to lead us to our final shape. And this one's, oddly enough, the easiest one of all. And that is the square. A square is a shape that has all of the characteristics that we've covered in this video. So it's going to have all the properties of a rectangle. And it's going to have all the properties of a rhombus. All of these are going to be put together. And so let's jump back to page 3 and look at a quick example of this. So here we have very simple drawing. EH is 5. That is the only identified given that they told me. So that might seem kind of confusing, but we want to keep in mind that we actually know a lot about a square without actually knowing any measurements. Let's go through the first few of these. GHF is the first angle they want us to find. So GHF is this angle right here. And as we know, a square is a specific type of rhombus. Therefore, we know that this angle has to be 90 degrees because diagonals are perpendicular. Moving on to DGH, okay? DGH is going to be right here. Now, we know an entire angle of a square is 90 degrees. And once again, because we know this shape is technically a specific rhombus, we can use the rhombus property that angles are bisected. Therefore, this angle has to be 45 degrees. Moving next to HF. In order to find HF, that's going to be this length right here. Also remembering that diagonals are equal. If this is 5, this side must also be 5. So right away we have the answer of 5. Lastly, we need to figure out the length of DE. And we can do this in a variety of different ways. But the easiest way, I would believe, is to create, once again, another right triangle. However you create that is up to you. You can actually go one of two ways. I need to find this length right here. And I know that if I draw it to here to the center, that's 90 degrees, which creates a right triangle. So once again, I'm going to draw that right triangle down below here. We're going to call this 5. We're going to call this X. And the angle that we have here is actually 45 degrees. So this is actually a 45, 45, 90 triangle. Once again, you can either use trigonometry for this or we can use special right triangles. Either way that you do it, if you did cosine of 45 equals 5 over X, Or if we knew that this is 5, then we know that the x has to be 5 root 2. And again, reminder, a 45, 45, 90 triangle will always be in the ratio of L, L, and L root 2. So that's how I'm actually getting that answer to being 5 root 2. You could also have given a decimal approximation for it as well. And so that'll conclude this video that talks about these properties. And here's another visual Venn diagram to come back at the end. So every shape we've talked about today is inside of this big parallelogram circle. But what we learned today is that you have rhombuses that have specific traits that make them unique from the general parallelogram. You then also have the rectangles, which have their own specific traits as well. But when you overlap the rectangle and the rhombus properties together, what you ultimately create is a square. And that's the relationship we're going to be working with here over the course of the next day or two. Thank you again for watching this video, and please reach out if you have any questions.